Problem number 11. Projectiles A, B, and C are simultaneously thrown off a cliff and take the trajectories shown. Neglecting air resistance, rank the times TE, TB, and TC they take to hit the ground. Solution for problem number 11. Since the x and the y directions are independent, the time to impact only depends on the initial vertical speed, which in turn determines the maximum height. The higher the maximum height, the longer the trajectory takes. In our case, highest trajectory is B, next one is A, and the lowest is C. So it means that the correct answer is D. That was a solution for problem number 11. Problem number 12. An object of mass small m equal 1 kg is attached to a platform of mass big M 4 kg with a spring of spring constant K equal 400 newtons per meter. There is no friction between the object and the platform, and the coefficient of static friction between the platform and the ground is mu equal 0.1. The object is placed at its equilibrium position and then given an horizontal velocity v. For what v will the platform never slip on the ground? Solution for problem number 12. First, let's count what is the force acting on the platform. That will be kx, where x is displacement. This displacement could be found from energy conservation. So we have 1/2 kx square equal 1/2 mv square. From here we can find what is x. That will be v multiplied by square root from m over k, and the force acting from the spring on the platform equal v multiplied by square root from mk. This force cannot exceed the force of friction. Maximum force of friction equal mu multiplied by small m plus big M multiplied by g. And we have to equalize this force of friction to force from spring to platform. That will be this equation. And from here we can find what is speed v. That will be this expression. And after putting numbers we have 0.25 meters per second. This is the critical speed which corresponding to answer C. Basically, answer A and answer B are correct too, but answer C is most allowable. So it means that the correct answer is C, and that was solution for problem number 12. Problem number 13. A car is driving on a semicircular racetrack. Its velocity at several points along the track is shown below. Which of the following could depict its acceleration at the corresponding points? Solution for problem number 13. Because the car is speeding up, its acceleration has a tangential component. It means that a component parallel to the racetrack. Because the car is turning, its acceleration also has a component v square over r directed towards the center of the track. Since v increases throughout the turn, this inward radial acceleration increases through the turn. For picture A we have only tangential acceleration, which is not good. For picture B we have only centripetal acceleration, and also constant, which is not good. For picture C we have only centripetal acceleration, which is increasing, but we don't have tangential acceleration. And for picture E we have acceleration constant in value, and we see that our acceleration must increase, so it's not good. And only picture D could correspond correct answer, because the value of acceleration is increasing. It has a tangential acceleration, and centripetal acceleration is increasing. So that's only correct answer is D, and that was solution for problem number 13. Problem number 14. A bacterium cell swims by rotating its bundle of flagella to counter a viscous drag force in the medium. The drag force F as a function of R, V, and nu only depends on the typical length scale of the cell R, its speed V, and the viscosity of the fluid nu, which has units of kilogram over meters by seconds. It is observed under a microscope that a cell of length 1 micron swims at about 20 microns per second. Estimate the speed of a cell of length 0.5 microns, assuming cells of all sizes generate the same amount of force from their flagella. Solution for problem number 14. Using dimensional analysis, we can see that force scale F could be found from this equation. Here on the right we have a combination of different powers for R, V, and nu. The only solution for this equation is A equal B equal C equal 1. So it means that force F proportional to R, V, nu. It means that if we decrease size twice, we have to increase speed twice. So it means that correct answer is C, and that was solution for problem number 14.